So let's do an example here. Let's say that we've got a board and it's being supported by ropes at each end. Okay, so this board, we'll call that mass 1. And let's say the mass 1 is 35.1 kilograms and it has a length of 3.34 meters. Okay. And we've got a worker standing on here, and we'll call that mass 2 at the center here. And let's say that mass 2 is 81.5 kilograms. So this would be like a window washer or something in a tall building. We've got the platform right here he's standing on. It's being supported by ropes at each end. Now, each rope has a tension here, and so T1 and T2, and let's say the ropes are identical, and the maximum tension that each rope can have is 800 newtons. Okay, so we look at it and we say, well, if the worker's standing in the center, then how much tension is on each rope? And so you look at it and you say, well, that's pretty straightforward. Okay, because the tension is going to be equal to 1/2 of the total mass times G because it's symmetric. Okay, and so that turns out to be equal to 572 newtons. So that's well below the maximum. And so you think, well, obviously this is good. So that means it can support the worker here. He can work and then move back and forth. But now the question is, we know from our previous work that if he moves off this way, the center of mass of the entire system moves over with him. And that means that tension 1 becomes less and tension 2 becomes bigger. And so now the question is, how far D from the center of the platform can the worker go before this rope reaches its breaking point and it separates? Okay, so we're holding this. The worker now is some distance x from this end. Okay. So what we want to do is we say that as the worker is going over here, free body diagram. Okay, we've got tension 1 here. We got tension 2 there. We got M1G down here. We got M2G right here. Now, we know that force up equals force down. So that means T1 plus T2 is going to equal M1G plus M2G. We also know that clockwise torque equals counterclockwise torque. Now, it's not rotating, so we can put this anywhere we want. And so what I'm going to do is I'm going to put my pivot point right here. So that means that if my pivot point is right there, the clockwise torques are both of these, and the tension provides the counterclockwise torque. So we have M1G L over 2 plus M2G times X, and that's going to be equal to T max times L, because that's when it breaks, is when he moves over so far distance x that it breaks. And so we look at that and we say, okay, and we can do some algebra here. Okay, so we're trying to solve for x. So M2gx is going to be equal to T max times L minus M1G L over 2. So x is going to be T max L minus M1G L over 2 divided by M2G. And so x is going to be equal to 800 newtons times 3.34 meters. minus M1, 35.1 kilograms times 9.81 meter per second squared times 3.34 meters over 2 divided by the 81.5 kilograms times 9.81 meter per second squared. And what you find is x is 2.62 meters. Now, that is 2.62 meters from the end down here. Once the person goes beyond that, then this rope breaks. So I want to know how far from the center was it. Well, the distance to the center is going to be L over 2. So L over 2 is going to be, that's going to be 3.34 meters divided by 2. So that's 1.67 meters. So D is going to be 2.62 meters minus 1.67 meters. And so that comes out to be 0.95 meters. So that is how far the person can walk away from the center point before that rope breaks.